The Oracle server uses work areas, called private SQL areas, to execute SQL statements and to store processing information. Whenever you execute a select or DML statement in a place SQL block, an implicit cursor is created by the place SQL engine. However, you can create and use explicit cursors according to your application requirement. Implicit cursors are created by the place SQL engine when a select statement is executed with the int clause, or when insert, update, or delete statements are executed in the place SQL block. The cursor closes after executing the statement associated with it. You cannot control an implicit cursor, but you can get information about the implicit cursor through its attributes. You must declare and define an explicit cursor, giving it a name and associating it with a select statement. Typically, the query returns multiple rows. You can process each row returned by the select statement through a for loop. The set of rows returned by a multiple row query is called the active set. Its size is the number of rows that meet your search criteria. The diagram in the slide shows how an explicit cursor points to the current row in the active set. This enables your program to process the rows one at a time. 1. In the declarative section of a place SQL block, declare the cursor by naming it and defining the structure of the query to be associated with it. 2. Open the cursor. The open statement executes the query, binds any variables that are referenced, and positions the cursor at the first row. The rows that are identified by the query are called the active set, and are now available for fetching. 3. Fetch data from the cursor. In the flow diagram in the slide, after each fetch, you test the cursor for any existing row. If there are no more rows to process, you must close the cursor. The fetch statement retrieves the current row, and advances the cursor to the next row until there are no more rows, or a specified condition is met. 4. Close the cursor. The close statement releases the active set of rows. It is now possible to reopen the cursor to establish a fresh active set. The active set of a cursor is determined by the select statement in the cursor declaration. It is mandatory to have an int clause for a select statement in place SQL. However, note that the select statement in the cursor declaration cannot have an int clause. This is because you are only defining a cursor in the declarative section, and not retrieving any rows into the cursor. The open statement executes the query associated with the cursor, identifies the active set, and positions the cursor pointer at the first row. The open statement is included in the executable section of the place SQL block. Open is an executable statement that performs the following operations. 1. Dynamically allocates memory for a context area. 2. Parses the select statement. 3. Binds the input variables, sets values for the input variables by obtaining their memory addresses. 4. Identifies the active set, the set of rows that satisfy the search criteria. Rows in the active set are not retrieved into variables when the open statement is executed. Rather, the fetch statement retrieves the rows from the cursor to the variables. 5. Positions the pointer to the first row in the active set. The fetch statement retrieves rows from a cursor, one at a time. After each fetch, the cursor advances to the next row in the active set. Consider the example in the slide. Two variables, v_empno and v_lname, are declared to hold the values that are fetched from the cursor. Examine the fetch statement. You have successfully fetched the values from the cursor to the variables. However, there are 6 employees in Department 30, but only one row was fetched. To fetch all rows, you must use loops. In the next slide, you see how a loop is used to fetch all the rows. The close statement disables the cursor, releases the context area, and undefines the active set. Close the cursor after completing the processing of the fetch statement. You can reopen the cursor if required. A cursor can be reopened only if it is closed. If you attempt to fetch data from a cursor after it is closed, an invalid _cursor exception is raised. You have already seen that you can define records that have the structure of columns in a table. You can also define a record based on the selected list of columns in an explicit cursor. This is convenient for processing the rows of the active set, because you can simply fetch into the record. Therefore, the values of the rows are loaded directly into the corresponding fields of the record. You learn to fetch data from cursors by using simple loops. You now learn to use a cursor for loop, which processes the rows in an explicit cursor. It is a shortcut because the cursor is opened. A row is fetched once for each iteration in the loop. The loop exits when the last row is processed, and the cursor is closed automatically. The loop itself is terminated automatically at the end of the iteration where the last row is fetched. As with implicit cursors, there are 4 attributes for obtaining status information about a cursor. When appended to the cursor variable name, these attributes return useful information about the execution of a cursor manipulation statement. You can fetch rows only when the cursor is open. Use the %isappend cursor attribute to determine whether the cursor is open. Fetch rows in a loop. Use cursor attributes to determine when to exit the loop. Use the %rowCount cursor attribute to do the following. Process an exact number of rows. Fetch the rows in a loop and determine when to exit the loop. The example in the slide shows how the %rowCount and %notFound attributes can be used for the exit conditions in a loop. In the given code, the exit condition for the loop was either that the cursor displayed 10 rows or the cursor cannot fetch any rows according to the select statement. The %rowCount attribute keeps track of the number of rows retrieved through the cursor. The %notFound attribute checks for the end of the active set of rows retrieved by the cursor. The output of the code displays 10 rows from the employees table. Note that there is no declarative section in this place, SQL block. The difference between the cursor for loops by using subqueries and the cursor for loop lies in the cursor declaration. If you are writing cursor for loops by using subqueries, you need not declare the cursor in the declarative section. You have to provide the select statement that determines the active set in the loop itself. You can pass parameters to a cursor. This means that you can open and close an explicit cursor several times in a block, returning a different active set on each occasion. For each execution, the previous cursor is closed and reopened with a new set of parameters. Each formal parameter in the cursor declaration must have a corresponding actual parameter in the open statement. The parameter data types are the same as those for scalar variables, but you do not give them sizes. The parameter names are for reference in the query expression of the cursor. If there are multiple sessions for a single database, there is the possibility that the rows of a particular table were updated after you opened your cursor. You see the updated data only when you reopen the cursor. Therefore, it is essential to have locks on the rows before you update or delete rows. In the absence of locks, the data would be updated inconsistently. You can lock rows in databases with the for update clause in the cursor query. Locks are used in databases to maintain data integrity when multiple users are trying to access data. The where current of clause is used in conjunction with the for update clause to refer to the current row in an explicit cursor. The where current of clause is used to perform an operation such as update or delete on the current row pointed by the cursor. The for update clause is specified in the cursor declaration. You must include the for update clause in the cursor query so that the rows are locked on open.